So for a long time, I've always wanted to be able to pass around a built-in ColdFusion function like trim or ucase or lcase or anything like that as a first-class citizen, essentially be able to pass around built-in functions just like you can pass user-defined functions. And especially with member methods and things like map and filter being a prominent part of the ColdFusion landscape now, I love to be able to do things like value.map and say pass in trim, right? Or values.map and pass in lcase, something to that effect. Of course, when you do this, you get a trim is not a defined variable or lcase is not a defined variable. So ultimately, what I really do in a production app is I would do something like, value, and then I would just inline the call to that built-in function, right? So essentially here I'm creating a proxy to the lcase function, which translates the set of arguments to my map operator to the underlying call to the built-in function, right? And part of this translation is not just the invocation here, but the paring down of arguments, right? Because the map operator doesn't just receive one argument. It's not a unary function, right? It receives index and collection. Now, if we then turned around and tried to pass all of those to the underlying lcase function, we get a different error, right? lcase is defined, but it's using the wrong number of arguments. So really what we would love to be able to do is not only pass around the built-in functions like first-class citizens, like user-defined functions, we also want a way to pare down in a particular context the number of arguments to a set of arguments that make sense for the particular built-in function. So ColdFusion is a super dynamic language, in part because we are allowed to do a lot of reflection at runtime to inspect the state of the runtime environment. And in Lucee specifically, we have a getFunctionData function, which takes the name of a built-in function and can return metadata about that built-in function, including the number of arguments that that function can take. So I thought to myself, well, maybe I can use that function to build a generic proxy to built-in functions that allows us to upgrade them to become first-class citizens, right? Or functions that can be passed around as references. So let's take a look at how I did this. So here is my upgrade BIF, my upgrade built-in function method, and it takes the name of the underlying built-in function. And we're going to use this Lucee-specific getFunctionData call, passing in the name of the underlying built-in function, and we're going to get this metadata about that built-in function. One of the metadata arguments, as I mentioned a minute ago, was arguments, which tells us the length and name of the arguments that can be used to invoke that function. So now I'm going to return a closure from this upgrade BIF. So upgrade BIF takes the name of a built-in function and then returns a function that can be used to invoke that underlying built-in function. And the bulk of the logic here is simply translates the arguments that get passed to the closure down into an argument list that can ultimately be used in an evaluate call. So evaluate here is taking the name of the built-in function, like trim, like lcase, like pad, left pad, I think, right? And then invokes it with a particular argument list. And the argument list, again, is all of this logic that goes into translating this argument list down into the evaluate argument list. So for example, if the arguments passed to the closure has the index of 1, meaning that it's probably being invoked as a ordered set of arguments, I can then slice that arguments list based on the BIF arity, right? So going back to my example here, I don't want to pass in index and collection to the underlying lcase. lcase is a unary function. It only takes one argument. So I want to say slice from 1 to the minimum of what the BIF arity or the built-in function arity is. So even if I get 3 arguments to that map callback, I want to only take the first one. And then I'm going to translate that into a number of argument references to the argument scope itself. And then I'm just going to join that as a list. So essentially what we're doing is creating an argument list for the evaluate. Same thing I'm doing here. If it's a key value, if it's a set of key value arguments, I'm just translating that into key equals arguments collection. So here I'm referencing the arguments by index. Here I'm referencing the arguments by key and passing them as key value pairs. And then again, in any case, I'm taking that defined arguments list and I'm passing it to the underlying built-in function using the evaluate. Okay, so that's the context. Now let's try and actually use this. So I'm going to create an array of values here, and these are all words that are mixed case and in reverse, right? Friend, good, my, hello. And what I'm going to do is try to call the map function a couple of times, and in each case I'm going to pass in a built-in function that has been upgraded to a first-class citizen. It's been upgraded essentially to a UDF. So first I'm going to reverse all of the values in the array, right? I'm going to map over and call the reverse. Then I'm going to randomly, 50%, 0, 1, either use the uCase built-in function or the LCase built-in function, and then I'm going to map over that values collection again. So ultimately what we'll get is a reversal of these strings and then randomly either an uppercasing or a lowercasing of those strings. Let's go ahead and run this. And you can see here we get the uppercasing. If we run it a couple more times, you get the lowercasing, uppercasing, lowercasing, right? So you can see that we're getting that random selection of the uCase and the LCase. And we're taking those built-in functions, we're proxying them with the upgrade BIF method, and then we're taking that upgraded method and we're just passing it around like we would any other user-defined function. So this to me is just a fun exploration of the highly dynamic nature of ColdFusion. I mean, ColdFusion would be even more dynamic if I could actually just take uCase and LCase and reverse and pass those around. Unfortunately, that's not yet a feature of the language, either in Adobe ColdFusion or Lucee CFML. But it is fun to see that you can use some dynamic reflection and introspection here to essentially build this feature into the runtime. And then you could even, going back to my previous post, you could take this upgrade BIF and you could make upgrade BIF a built-in function using a Lucee extension. So you wouldn't even have to have all of this defined. You could just install it and then suddenly upgrade BIF becomes available everywhere. Again, just a fun exploration. In reality, in production, this is what I use, right? I just inline a closure that proxies the invocation of the method. But there's just something really appealing about being able to pass these in just like this. And especially in this kind of a case where I might need to choose between one or two different types of built-in functions. But anyway, again, just a fun exploration. Love ColdFusion, love how dynamic it is, and it's really just a joy to work with in so many ways.